So to figure out how to think about a z-score, let's go back to our SAT example that we started off with, and let's consider what happens if we don't have one of these nice, easy numbers to look at. And instead, we find ourselves with our own score, and we're posed with the question, where do I fit on all this? So let's say, for instance, that we are talking to a student named Larry, and Larry gets let's pick a number. Let's say he gets an 1125 on his SAT. Well, we can see where he fits. We can see that Larry fits someplace in this region. He's somewhere between 1060 and 1255. But we'd like to know exactly where he is and what number of students he scored better than. So we need to find the z-score for Larry. And here's how we're going to find the z-score, and you'll want to make sure that you jot this down someplace. It's always whatever actual score you have minus the average, x bar, divided by the standard deviation. All right, and there is a page in the book that shows this formula. And I'll get you that page number here in a minute. So for our SAT example, the score that Larry has, so Larry's z-score is going to be the 1125 minus the x-bar, or the average, and on this problem, on the SAT, it was 1060, divided by 195. That is his z-score. All right, so a quick calculation with our our calculator. We come up with 1125 minus 1060, so that gives us 65 over 195. And so 65 divided by 195 is 0.33 repeating. Good job, Mr. Hampton, picking a score that has a nice, lovely decimal on it. 0.33 repeating. Well, that's not on one of our lists. It's not 1. It's not z equals 1, it's not z equals 0, it's in between those two. Fortunately, mathematicians came up with a way to deal with that, and it is called a z-table, and it is massive. And on the test, you will have to read a little bit of the z-table off of the test. Here's what it looks like in its entirety. It's big, it's long, it's got lots and lots of numbers on it. The good news is, once you understand how it works, it's not that hard to work with. So first there's two pieces. There's a number on the left side and a number on the top that you'll have to look at. And if you look at the numbers on the top, you will notice that they have 2 decimal places, whereas the numbers in the left column have only 1. So for instance, let me pick a random place to look at, and we'll pick this guy right here. I don't know why I picked that, I just want to look at it. The z-score that is represented here is negative 2.2 connected with 0.05. So negative 2.2, negative 2.2 plus 0.05 means the z-score that is representing is negative 2.25. All right. Now, what does that number inside the circle mean? Let's not worry about it totally just yet. Let's find another one. Let's look at this guy right here, 0.001. The z-score that this represents is, we start over here on our left side with the 0.30, and we look up above with the 0.08. So this must be, try the negative sign there. This must be a negative 3.0 plus 0.08. So this z-score would be negative 3.08. All right. So that's how we read a z-score. Now, what do these numbers inside of here mean? If you look back up at this picture, the shaded region is the percent of data that is to the left of that z-score, to the left of the z-score. Now, perhaps you remember from some of the videos that I had you watch at the beginning that this whole thing is always 100%. 100% of the data is inside that shaded region. All that stuff, 100%. So that means that there should be 50% that is to the right of this number. This should be 50%. And to the left of this dotted line in green should be another 50%. 50% of the data on either side of the line. So let's see if we can find that out. Right here in the middle is a z-score of 0. So I'm going to scroll down my table and find where a z-score of 0 is, which is right about here. Notice that it's changed from negative numbers to positive numbers. Here is a z-score of exactly 0. And you can see that inside that it says 0.50. So the number that we see there is always to the left of the z-score. This means that 0.50, or 50% of the data, is to the left, always to the left on this table, is to the left of z equals 0. Well, in our problem, our SAT problem, we had a 0.33. So we need to find 0.3, which is right here. And then we have to find the second 3, which is up here, and find out where these two cross. All right? And we got a 0.6293. So that means on our SAT table that we had over here, where we had looked at Larry, let's go back to the actual thing, 0.6293. From the table, we have 0.6293. So what this means is that we have found that Larry, who is right here at z equals 0.33, that if we were to draw a line right up to there and shade to the left of it, that shaded region would represent 62, let's try that again, 62.93% of all the students. That means that Larry scored better than 62.9% of the students. All right, so the process is you find a z-score, you look it up on the table, and then you interpret the results. Now, in our book, there is a table. I will put that in the notes. There's a table in our book on page, oh dear, where is it at? It's all the way in the back someplace. We'll find it. Hang on. It'll be in the notes.